February 26, 1963. A closed hearing room in the Capitol. No cameras, no press releases, just a Senate subcommittee, a stack of classified documents, and an admiral about to say something the Pentagon did not want on the record. Four-star Admiral Frederick Ashworth had come to testify about an airplane. Not just any airplane, the one his own Navy had just been ordered to fly. He told the subcommittee plainly that the Navy's own evaluation board had rejected it. Boeing's design had been the board's first choice in every round, on every metric that mattered. And yet the contract, worth billions of taxpayer dollars, had gone to a different company entirely. The man who signed off on that decision wasn't a general. He wasn't an admiral. He was the Secretary of Defense, and he had just overruled 200 of his own experts in both the Air Force and the Navy to force one single airframe onto two branches of the military that had never agreed on anything before and would agree on even less once they were ordered to share a cockpit. One aircraft, two services. One would eventually call it a masterpiece. The other would call it, on the record, unsafe to land on their own ships. This is the story of how that happened and who paid for it. For 15 years, one rule had never been questioned inside the Pentagon. Each service built its own airplanes. The Air Force designed for the Air Force. The Navy designed for the Navy. Different missions, different physics, different machines. Nobody in either uniform seriously proposed sharing an airframe because nobody believed it could work. A fighter built to survive a catapult launch and a 500-mile-an-hour carrier landing had almost nothing in common, structurally, with a fighter built to scream across Soviet airspace at treetop height, undetected, carrying a nuclear weapon toward a fixed target thousands of miles from home. By 1960, that divide had only widened. The Air Force's Tactical Air Command wanted a replacement for the aging F-105 Thunder Chief, something that could fly low, fast, and far, hugging the terrain beneath enemy radar, using a new and largely unproven idea called terrain-following radar to fly at night, in weather, at treetop altitude, without a pilot's hands ever touching the stick during the most dangerous seconds of the mission. The Navy wanted something else entirely, a fleet defense interceptor, an airplane that could loiter for hours far out from the carrier group, carrying a radar powerful enough and a missile long-ranged enough to shoot down Soviet bombers before they ever got close enough to launch an anti-ship missile. Two missions, two sets of physics, two airplanes that, by every precedent in American military aviation, should never have been asked to share a single design. Then, in 1961, a new Secretary of Defense arrived at the Pentagon with a different set of assumptions entirely. A former president of the Ford Motor Company, a man who had made his name proving that shared parts, shared assembly lines, and shared components could save American industry millions of dollars a year. Robert McNamara did not see two incompatible aircraft. He saw two service branches unwilling to cooperate, and he saw an opportunity to force the kind of efficiency the automobile industry had already learned to demand of itself. He gave the program a name, the Tactical Fighter Experimental, TFX, for short. One airframe, two services, a single production line building fighters for the Air Force and the Navy at the same time, with the same engines, the same basic structure, the same radar architecture wherever the mission allowed it. Almost nobody who understood the actual engineering believed it could be done. McNamara believed the resistance was cultural, not physical. Old Guard officers protecting Old Guard habits. He was determined to prove them wrong, and in November 1962, he was about to make a decision that would put that belief to the ultimate test. Not in a wind tunnel and not in a design review, but on the floor of the United States Senate. To understand why so many engineers doubted the TFX program from day one, it helps to understand exactly what each service was demanding, because on paper, the two requirements didn't just differ, they contradicted each other at the level of basic physics. The Air Force needed an airplane built around one number, low-altitude speed. Terrain-following radar, a system that read the ground ahead of the aircraft in real time and adjusted altitude automatically, allowing a pilot to fly at treetop height without staring at a screen the entire time, only worked if the airframe underneath it could handle the punishment of high-speed, low-level flight through turbulent air. That meant a heavy, rigid structure. It meant wings swept back tightly enough to punch through dense low-altitude air at supersonic speed without tearing themselves apart. It meant an airplane built to survive hours of violent buffeting, close to the ground, in bad weather at night. The Navy needed almost the opposite airplane. A carrier-based interceptor lived and died by two numbers that had nothing to do with speed: weight at landing and wing loading. Every pound an airplane carried back to the ship after a mission had to be absorbed by an arresting hook slamming into a wire, on a deck the size of a city block, pitching an open ocean swell. The Navy's requirement, later formalized as the F-111B, called for an aircraft under roughly 55,000 pounds at landing weight, wings spread wide enough for the low approach speeds a carrier deck demanded, and a nose large enough to house an enormous new radar. The AN/AWG-9, paired with the Navy's next-generation missile, the AM-54 Phoenix, designed to kill Soviet bombers at ranges of over 100 miles before they ever got within striking distance of the fleet. Long-range, low-altitude interdiction on one side, carrier-compatible fleet air defense on the other. One aircraft was supposed to satisfy both. The engineering solution that made the whole program theoretically possible was a single piece of technology. Neither service had ever flown in a production aircraft before: the variable sweep wing, a wing that could physically pivot on a hinge mid-flight, sweeping forward for slow-speed lift during takeoff and carrier landings, then sweeping back into a narrow delta shape for high-speed, low-altitude dash. On paper, it was the one mechanism flexible enough to serve both missions at once. In practice, it was untested at this scale, unbelievably complex to manufacture, and it added weight and mechanical risk to an airframe that already had almost no margin left to give. Every additional pound the Navy's radar and missile system demanded pushed against every pound the Air Force's low-altitude structural requirements demanded. There was no version of the TFX where both services got everything they needed. Every design decision was a trade, and every trade meant someone's requirement got compromised to protect someone else's. Both services knew this going in. Both services said so on the record before a single prototype was ever built. McNamara pressed forward anyway, because in December of 1962, it wouldn't be the engineers who decided which company would build this airplane, and which design would win, and which one wouldn't, was about to become the most contested contract decision in the history of the Pentagon. Two companies made it to the final round: Boeing and General Dynamics of Fort Worth, Texas. Both submitted detailed proposals. Both went through months of technical review by a joint evaluation board. Engineers and officers from both the Air Force and the Navy, tasked with judging which design actually came closest to meeting the impossible dual requirement. The board did not split its verdict. Round after round, through 4 separate rounds of design revisions and resubmissions, the evaluators reached the same conclusion: Boeing's design was better. Air Force Chief of Staff General Curtis LeMay later told Congress that nearly 200 experts had spent almost a year comparing the two proposals, and Boeing had won on the merits every time. Admiral Frederick Ashworth, testifying for the Navy, laid out 4 specific technical reasons his service preferred Boeing's airframe over General Dynamics, reasons that, on paper, should have settled the question before it ever reached a cabinet secretary's desk. On November 24, 1962, Robert McNamara overruled all of it. He selected General Dynamics, not because its design had won the technical competition, but because, in his judgment, it offered greater long-term commonality between the Air Force and Navy variants. When the Senate subcommittee that would soon investigate the decision went looking for the paper trail behind it, investigators found exactly one document supporting the choice, a 5-page memorandum signed by McNamara alongside the Secretaries of the Navy and the Air Force, dated just 3 days before the contract award was publicly announced. Against that single memo stood a year of formal evaluation from officers in both services that had said the opposite. General Dynamics signed the contract on December 21, 1962. The reaction was immediate. Senator Henry Jackson of Washington, Boeing's home state, asked the Permanent Subcommittee on Investigations to examine exactly how the decision had been made. What began as a routine inquiry became, within weeks, one of the longest and most extensive congressional investigations of the Cold War era. The McClellan hearings, named for Subcommittee Chairman John McClellan of Arkansas, ran across 46 separate hearing days between February and November of 1963, filling more than 2,700 pages of printed record. Because so much of the TFX's technical detail remained classified, nearly every session was held behind closed doors, with censored transcripts released to the public the same day, sentence by sentence, for a nation increasingly convinced something had gone wrong. What the hearing surfaced was not a single smoking gun, but a pattern investigators found difficult to ignore. Two of McNamara's closest associates in the decision, Deputy Secretary of Defense Roswell Gilpatrick and Secretary of the Navy Fred Korth, both had documented prior business ties to General Dynamics. Korth's own bank in Fort Worth, it emerged, had a financial relationship connected to the very contractor he had just helped select. By October 1963, the pressure had become too great, and Korth resigned from the Navy Secretary's office altogether. Whether political pressure from Texas, General Dynamics' home state, and Vice President Lyndon Johnson's home state had shaped the outcome was alleged by multiple witnesses during the hearings, though never conclusively proven on the record. The press had already settled on its own verdict. Reporters began calling McNamara's program, with open derision, the Flying Edsel, a pointed reference to his years-running Ford Motor Company and to Ford's own infamous commercial failure. Contemporary estimates place the total value of the TFX contract at roughly $7 billion. A staggering sum for a single aircraft program in 1963 dollars, and one that would climb even further before a single production aircraft reached a squadron. The investigation could not undo the decision. General Dynamics kept the contract, but the airplane it now had to build, an airplane that still had to satisfy two services that had never wanted to share one in the first place, was about to reveal exactly how much had been sacrificed to make commonality possible on paper. On paper, the aircraft that emerged from the winning General Dynamics design was elegant in its ambition. In the metal, it would prove to be two very different airplanes wearing the same name. The heart of the design was the variable sweep wing, a wing mounted on a massive steel pivot, capable of rotating from 16 degrees, nearly straight out from the fuselage for maximum lift at low speed, back to 72.5 degrees, folded almost flush against the body for supersonic dash. Extended forward, the wing let the aircraft take off and land in as little as 2,000 feet, a critical requirement for a Navy interceptor operating off a pitching carrier deck. Swept fully back, the same aircraft could punch through the transonic barrier at low altitude or climb to high-altitude supersonic speeds, a single airframe, in theory, doing the job of two specialized designs. General Dynamics paired the airframe with a new afterburning turbofan, the Pratt & Whitney TF-30, itself a first for military aviation, the earliest turbofan engine ever fitted to a supersonic fighter. And rather than conventional ejection seats, the design used something almost no other American fighter of the era carried, an escape module. In an emergency, the entire cockpit section, not just the seats but the whole crew compartment, would separate from the aircraft as a single sealed capsule, slowed by parachute, cushioned by an airbag on impact, and watertight enough to float if the crew came down over open water. It was engineered specifically for the F-111's low-altitude mission profile, where a conventional ejection at treetop height and near sonic speed gave a pilot almost no margin for survival. Two variants split off from this shared foundation. The F-111A, built for the Air Force, carried the low-altitude strike mission the service had asked for from the beginning. Terrain-following radar, a bomb bay and underwing hardpoints for conventional or nuclear ordnance, and a fuselage optimized for the punishing structural loads of high-speed flight close to the ground. The F-111B carried the Navy's half of the bargain, and it was here that the compromise at the center of the entire program became unavoidable. To meet the Navy's fleet defense mission, the F-111B needed the enormous AN/AWG-9 radar and the AM-54 Phoenix missile system, a combination powerful enough to track and engage multiple targets more than 100 miles out. But every pound of that radar and missile system fought directly against the Navy's second non-negotiable requirement, a landing weight light enough for a carrier's arresting gear to catch safely at the low approach speeds carrier operations demanded. General Dynamics had never built a carrier aircraft before. For the naval variant, the company brought in Grumman, a company with decades of carrier aircraft experience, as a subcontractor, hoping Grumman's expertise could resolve what the paper design alone could not. At the outset, General Dynamics projected the two variants would share roughly 80% of their major structural components, the entire financial and strategic logic behind McNamara's commonality argument in the first place. It was a number built into the original justification for the contract. The figure that was supposed to prove the whole gamble had been worth the political cost of overruling two service evaluation boards. It would not survive contact with the airplane itself. The contract fight of 1963 had been about who got to build the airplane. What followed, over the next several years, was a quieter and more damning argument about whether the airplane the Navy was being handed could actually do the job it had been designed for. From the earliest design reviews, the F-111B's weight kept climbing. Every engineering fix added mass, reinforced structure to handle carrier landing stress, additional systems to integrate the AWG-9 radar, wiring and hydraulics needed to make the swing wing mechanism reliable enough for fleet service. Naval aviators who flew early test versions reported an aircraft that felt sluggish and underpowered for the split-second maneuvering a carrier approach demanded, an airplane fighting its own weight on every landing. The Navy's senior leadership had already gone on record about their preference for Boeing's design back in 1963, but as the F-111B moved through flight testing in the years that followed, a second and more specific set of warnings began surfacing, not about which company should have won the contract, but about whether the airplane itself, as built, could safely operate off a carrier deck at all. Landing weight figures that kept exceeding projections. Approach speeds higher than the Navy's own safety margins allowed. A radar and missile system so heavy that engineers were running out of places to cut weight without gutting the very capability the Navy needed the airplane for in the first place. McNamara's defense, both in the press and before Congress, rested on the same principles he had used to justify the original contract decision: commonality between the services and the long-term growth potential of a shared airframe. He argued that early performance shortfalls were normal in any new aircraft program, that the shared production line would still save the Pentagon enormous sums over the life of the program, and that abandoning the naval variant now would waste the investment already made. It was an argument built on projected savings and institutional discipline, not on the flight test numbers the Navy's own pilots were reporting back from the cockpit. Inside the Navy, the political cost of disagreement was becoming its own kind of warning. Admiral George Anderson, Chief of Naval Operations during the original 1963 contract hearings, would later say he had effectively been forced out of his position for failing to fully back McNamara's decision when questioned by Congress. The lesson was not lost on the officers who came after him. For much of the 1960s, it was widely understood within the Pentagon that publicly voicing doubt about the F-111B's viability could be a career-ending move, a Chief of Naval Operations ? Next to your name, not a technical assessment on the record. That silence did not mean the doubts had disappeared. It meant they were being kept out of the hearing room. The aircraft kept flying, the weight kept climbing, and the gap between what the Navy had been promised in 1961, one shared airframe, doing two jobs, at a fraction of the cost of building two separate fighters, and what the F-111B was actually proving capable of on a carrier deck, kept widening with every test flight logged. Something would eventually have to give. It would take a change in leadership at the Pentagon and a Navy officer willing to risk his career one more time in front of the same Senate committee room where this had all started, before anyone in a position of real power was willing to say so out loud. While the Navy's version of the F-111 struggled with weight, the Air Force's version was fighting a different battle entirely, one buried inside the very structure that made the swing wing possible in the first place. At the center of every F-111, where the two wings pivoted, sat a single massive steel forging called the wing carry-through box, the structural spine that transferred the load of both wings into the fuselage, absorbing every ounce of stress generated by high-speed, low-altitude flight. It was manufactured from a high-strength steel alloy called D6AC, chosen for its ability to handle enormous loads in a compact, lightweight structure. On paper, it was strong enough for a service life of thousands of flight hours. In practice, the steel had a flaw no one had caught in time. Fracture toughness, the ability of a metal to resist a crack growing once it started, varied more than engineers had accounted for, batch to batch, within the same alloy. Somewhere inside the carry-through structure of certain early aircraft, tiny manufacturing defects, some no more than a fraction of a millimeter across, sat undetected. Under the repeated stress of high-speed flight, a defect that small could grow, cycle by cycle, invisible from the outside, until the metal around it simply gave way. On December 22, 1969, it did. An F-111A flying a training bombing run out of Nellis Air Force Base in Nevada suffered a catastrophic failure in the wing carry-through box. The wing separated from the aircraft in flight. The crew's escape module, the same sealed capsule engineered to save them in exactly this kind of emergency, fired. But the failure happened so violently and so far outside the module's designed operating envelope that it offered no chance of survival. Both crew members were killed instantly. The Air Force grounded the entire F-111 fleet. What followed was one of the most extensive structural investigations in the history of American military aviation. Every airframe that had already left the factory, more than 200 aircraft, had to be pulled from service and subjected to a new procedure called cold-proof load testing. The entire wing carry-through structure chilled to extreme low temperatures, far colder than any operational flight condition, then loaded to stresses beyond anything the aircraft would ever encounter in the air. The logic was brutal but sound. If a hidden flaw existed, cold temperatures made brittle steel more likely to crack, and a controlled failure on the ground was infinitely preferable to a failure in flight. Aircraft that survived the test returned to service. Aircraft that did not were pulled from the fleet permanently. The grounding and the retrofit program cost months of production schedule and consumed enormous engineering resources at a moment when the Air Force needed every available F-111 in Southeast Asia. It was by this point only the latest in a string of technical problems that had dogged the aircraft since its earliest flight tests, engine and inlet compatibility issues that had plagued the F-111's supersonic performance, and a troubled first-generation digital avionics system that had proven far less reliable than the analog systems it was meant to replace. The damage reached beyond American airspace. Australia, which had committed to purchasing the F-111 years earlier as the F-111C, halted acceptance of its own aircraft in the aftermath of the structural crisis, leasing American F-4E Phantoms to cover the gap while engineers worked to prove the wing failure had been solved for good. By the early 1970s, the aircraft that Robert McNamara had promised would save the Pentagon money through shared engineering was now the subject of a second congressional inquiry. This one focused not on who had won the contract, but on whether the government had understood, at the moment it signed that contract, just how much engineering risk it was actually buying. And in the Navy, a separate reckoning was already underway. The airplane the admirals had warned about in 1963 was about to run out of chances. February 29, 1968. Robert McNamara resigned as Secretary of Defense. For nearly 7 years, his authority had been the single force holding the F-111B program together against a rising tide of technical failure and institutional resistance. Within the Pentagon, it had long been understood that publicly opposing the program while McNamara held office carried real professional risk. The moment he was gone, that risk went with him, and the doubts that had been building quietly for years finally found their way into the official record. Within a month of McNamara's departure, the Senate Armed Services Committee, chaired by Senator John Stennis, convened a new round of hearings. This time, the testimony arrived without hesitation. Fed questions by an enterprising Navy officer working behind the scenes, the Deputy Chief of Naval Operations told the committee plainly, on the record, that the Navy's preference was for a different fighter entirely. Not the F-111B, not any version of it, but a new aircraft built from the ground up for the fleet defense mission the Navy had been describing since 1961. The testimony that followed on the F-111B's engine problems was, if anything, more damaging. Performance shortfalls that had been managed quietly for years were now laid out in detail before the committee. An aircraft still struggling to meet the weight and approach speed margins carrier operations required, years after the program had begun, with no engineering path left to close the gap. Stennis had what he needed. Congress cut off funding for the naval variant, and the F-111B was formally canceled in July 1968. Only 7 aircraft had been built. 7 airframes, Against an original program that had promised the Navy a fleet of carrier-based interceptors, sharing the bulk of its structure with the Air Force's own fighter, the entire commonality argument that had justified overruling 2 evaluation boards derailed a Secretary of the Navy's career and consumed 6 years of congressional scrutiny, reduced to 7 aircraft that would never see fleet service at all. But cancellation did not mean the engineering died with it. Grumman, the same company General Dynamics had brought in as a subcontractor for its own lack of carrier experience, had spent years working directly with the F-111B's most advanced systems, the AWG-9 radar, the AIM-54 Phoenix missile, the basic swing-wing architecture itself. When the Navy went looking for its next fighter, it turned back to Grumman, and Grumman did not start from nothing. The company carried the radar, the missile, the engine concept, and the variable sweep wing forward into an entirely new airframe, one built from the outset around the Navy's actual carrier requirements, rather than compromised by an Air Force mission it was never meant to share. That aircraft entered service in 1974 under a new name, the F-14 Tomcat. The Navy had not simply rejected the F-111. It had taken the most valuable parts of the program McNamara forced upon it, stripped away everything that had made the compromise unworkable, and built the fighter it had wanted from the very beginning, one that would go on to define naval aviation for the next 3 decades. The Air Force, meanwhile, still had an airplane on its hands, a grounded fleet, a structural crisis barely contained, a program that Congress had investigated twice and the press still called the Flying Edsel. What almost nobody expected in 1968 was that this same airplane, mocked, half-canceled, and still recovering from a fleet-wide grounding, was less than 2 decades away from flying one of the most audacious combat missions in the history of American air power. With the naval variant gone, the Air Force did the one thing the program had never truly been given the chance to do from the beginning: build the F-111 for a single coherent mission, without a second service pulling the design in an incompatible direction. The results came fast. The F-111D introduced improved avionics. The F-111E refined the aircraft's high-speed inlet design, fixing one of the persistent technical flaws from the program's earliest years. The F-111F, the last and most capable Air Force variant, paired more powerful TF-30 engines with a new targeting system called PaveTac, an electro-optical and laser designation pod, mounted in the aircraft's weapons bay, that let a crew acquire a target visually at night, lock a laser onto it, and guide a bomb onto that exact point with an accuracy earlier F-111 variants could never have matched. A parallel program converted dozens of earlier F-111A airframes into an entirely new role, the EF-111A Raven, stripped of bombing equipment and packed instead with electronic warfare systems capable of jamming enemy radar across an entire strike package's path into contested airspace. The aircraft that had spent a decade defined by a canceled Navy variant and a fleet-wide grounding was now, quietly, one of the most capable strike platforms in the American arsenal. It simply hadn't been tested in combat conditions that could prove it. That test came on the night of April 14, 1986. 10 days earlier, a bomb had torn through a nightclub in West Berlin, killing 2 American servicemen and a Turkish civilian, wounding more than 200 others. American intelligence linked the attack directly to the Libyan government. President Ronald Reagan ordered a retaliatory strike against targets tied to Libyan leader Muammar Gaddafi, including facilities near his own compound outside Tripoli. The mission was codenamed Operation El Dorado Canyon, and the aircraft chosen to fly it, the only aircraft in the American inventory judged capable of completing a mission this demanding, was the F-111F. France, Spain, and Italy refused to grant overflight rights for the strike force. 18 F-111Fs, escorted by 4 EF-111 Ravens flying electronic jamming cover, took off from RAF Lakenheath in England and flew around the entire Iberian Peninsula to reach Libya, a diversion that stretched what should have been a manageable strike mission into roughly 13 hours in the air, with as many as a dozen aerial refuelings each, conducted at night in total radio silence over open ocean. It remains to this day one of the longest combat fighter missions ever flown. 25 surface-to-air missile sites defended Tripoli. The F-111Fs pressed through them to their targets. One aircraft, call sign Karma 52, was lost over the Gulf of Sidra. Its two-man crew, Captains Fernando Ribas Dominici and Paul Lawrence, the only American losses of the operation. The rest of the strike force delivered its ordnance and turned for home. It was after 25 years of congressional hearings, structural failures, and a canceled sister program, the F-111's first unambiguous vindication in the eyes of the American public. An airplane once dismissed as a flying Edsel, now credited with flying one of the boldest strikes in the history of American air power. 5 years later, in the opening hours of Operation Desert Storm, the F-111F would fly again. This time in far greater numbers, more than 2,500 sorties over the course of the war, developing a laser-guided bombing tactic against armored vehicles that crews nicknamed tank plinking. By the time the war ended, the F-111F had flown more missions and struck more targets than any other aircraft in the American order of battle. The airplane that two services had once refused to share had finally found the one job it was built to do, 30 years after the men who designed it first tried to force it to do too. By the time the last F-111 left active service in 1996, followed 2 years later by the final F-111 Raven, General Dynamics had built 562 aircraft across every variant of the program: 159 F-111As, 96 F-111Ds, 94 F-111Es, 106 F-111S, 76 FB-111A strategic bombers, 24 F-111Cs for Australia, and the 7 F-111Bs that had started it all and never left the test program. 42 of the surviving F-111As were converted into EF-111A Ravens, carrying the electronic warfare mission forward long after the aircraft's bombing role had been handed to newer designs. Each mission the F-111 had once carried eventually passed to a purpose-built successor. The precision strike role went to the F-15E Strike Eagle. The strategic bomber variant's job was absorbed by the B-1B Lancer. The electronic warfare mission moved first to the Navy's EA-6B Prowler and later to the EA-18G Growler. The same lineage of carrier-based jamming aircraft descended, indirectly, from the very service that had walked away from the F-111 program in 1968. The verdict on the airplane itself is more complicated than the flying Edsel headlines of 1963 ever allowed for. Later analysis of the original contract decision, including a detailed reassessment by historian Robert J. Art, found that McNamara's reasoning was not simply politically motivated cronyism, as the press had framed it at the time. Boeing's design, by some technical accounts, had not actually met the Air Force's low-altitude supersonic dash requirement as cleanly as the evaluation board's preference suggested, and questions about the realism of Boeing's cost projections were not unfounded. McNamara was not entirely wrong about the airplane. He was wrong about how much could be shared between two missions that never should have been merged in the first place, and he was wrong to treat 2 years of warnings from his own service secretaries and chiefs of staff as bureaucratic resistance rather than engineering fact. The F-111, that flew over Tripoli in 1986 and over Iraq in 1991, was, in the end, a genuinely capable aircraft. It simply took the Air Force building it alone, without the Navy's incompatible mission bolted onto the same airframe, to prove it. The idea did not die with the F-111B. Decades later, a new generation of Pentagon planners would attempt something even more ambitious: a single fighter design, built to serve not two branches of the military, but three: the Air Force, the Navy, and the Marine Corps, under a program called the Joint Strike Fighter. The aircraft that emerged, the F-35, would face its own decade of cost overruns, technical delays, and congressional scrutiny, chasing the same promise of shared savings across incompatible missions that had defined the TFX program 60 years earlier. The lesson of the F-111 was never that joint programs cannot work. It was narrower and harder to forget. An airplane can be forced to serve two masters. It cannot be forced to serve them equally. One service got a fighter that shot down Soviet bombers off the deck of a carrier for 30 years. The other got a fighter that flew the longest combat mission in the history of American air power and never landed on a ship at all.